You ever think about how rivers kind of have personalities? I mean, some are super dramatic and moody, raging one season and then just quiet the next. And others, they're just these steady giants, always powerful, always flowing. But why? What is it that gives a river its own unique character? Well, to find that out, we've got to look a lot deeper, right into the very pulse of the water itself. Yeah, it's a pretty fascinating question, right? And the answer? It all comes down to this hidden annual rhythm, a pulse that beats deep inside every single river basin on Earth. And to really get it, we first need to know what it's called. So, scientists call this pattern a river's regime. And honestly, that analogy on the slide is perfect. Think of it exactly like a heartbeat on a medical chart. It tracks a river's life over one full year. Its peaks, its lulls, its totally unique rhythm. And today, we're basically going to become cardiologists for three of the world's most incredible rivers. So here's the game plan. First, we'll break down the key ingredients that make up any river's rhythm. Then we're taking a trip to three very different places: the frozen Yukon, the tropical Amazon, and the mountainous Indus. After that, we'll put it all together and see why understanding all this matters now more than ever. Okay, so what actually creates this unique heartbeat for every river? Well, it's not random at all. It's actually a predictable recipe cooked up by a trio of really powerful environmental forces. So first up is climate. Climate is the big boss, no question. It decides how much water shows up and whether it's coming down as rain or snow. But then you've got geology and soils, and they're like the crucial managers on the ground. Do they soak that water up like a giant sponge, or do they just send it rushing off into the river channel? This combo, climate, rock, and soil, is the secret recipe we're going to be exploring. All right, our first stop takes us way up north to the home of the Yukon River. Now, this is a land of extremes, and believe me, the Yukon's rhythm is a perfect reflection of that. Whoa, okay, just look at the drama on this chart. That winter flow, it's barely a trickle. The river is basically hibernating, completely locked in ice. But then, summer hits, and the flow just absolutely explodes. So what's behind this total Jekyll and Hyde personality? The secret is snow. All winter long, precipitation just builds and builds as this massive snowpack. It's like a giant bank account of frozen water. And when spring finally shows up, that whole account gets cashed in all at once. And here's the kicker. The ground is frozen solid, that's permafrost, so the meltwater can't soak in. It has literally nowhere to go but straight into the river, creating this incredibly sharp, dramatic spike. This is what's called a nival regime. Okay, time for a complete 180. We are leaving the frozen north and traveling to a totally different world, the heart of the tropical rainforest, to check in on the mighty Amazon River. And man, this chart just says it all, doesn't it? Compare this to the Yukon for a second. The Amazon's low point, its so-called dry season, is still unbelievably massive. This river doesn't hibernate. It's an absolute powerhouse all year long that just gets even more powerful in the wet season. So the Amazon story is all about consistency. It's driven by just relentless, heavy rainfall. But here, the land plays a totally different role. Instead of frozen permafrost, you have these deep soils and a super dense rainforest canopy that act like a massive natural sponge. They soak up all that constant rain and just release it slowly and steadily. This smooths everything out and keeps the river powerful year-round. This is a classic equatorial regime. All right, for our final case study, we have the Indus. And this one, well, this one's more complex. It's a true hybrid, getting its water from two very different but equally powerful sources. It's really a story of both ice and rain. You see, the Indus gets this incredible 1, 2, 3 punch every single summer. First, the Himalayan glaciers, these ancient towers of ice, start to melt in the intense heat. Second, all the winter snowpack from the mountains adds to that flow. And then, just as things are really ramping up, the famous South Asian monsoon arrives, dumping enormous amounts of rain into the exact same area. All three of those sources combine to create a truly massive summer peak. And that is what we call a mixed regime. Its pulse is a combination of that nival regime we saw in the Yukon, the snow and ice melt, and a rain-driven or pluvial regime from the monsoon. It's also a great reminder that humans have become a key ingredient in many rivers' recipes because its natural flow is heavily managed by dams and irrigation systems.
So, we visited 3 rivers with 3 completely different personalities. Let's just lay out their master recipes side by side to make it all crystal clear.
So this right here, this table is really the whole story in a nutshell. For the Yukon, you've got a polar climate and snow melt giving it that sharp, spiky peak. For the Amazon, it's a tropical climate and rain all year, creating that high and steady flow. And for the Indus, it's that combo of mountain ice melt and monsoon rains that produces a really powerful mixed summer peak. 3 rivers, 3 totally different recipes.
Understanding these recipes isn't just a cool academic exercise. It is becoming critically important because the fundamental ingredients themselves are starting to change.
This is the question that hydrologists, governments, and literally millions of people who depend on these rivers are all asking right now. The heartbeats that we've all come to know and rely on, well, they're becoming a lot less predictable. For a river like the Yukon, a warmer world can mean earlier, more chaotic spring melts, which could trigger these really sudden, destructive ice jam floods downstream. For the Amazon, deforestation can weaken that natural sponge effect, which impacts everything from hydropower to the unique ecosystems that need that steady flow. And for the Indus, wow, the glaciers that provide that crucial first pulse of summer water are shrinking, threatening the long-term water and food supply for millions, and raising the stakes in an already tense part of the world. And that is why this matters so much. A river's regime isn't just some line on a graph. It tells us when to plant crops, how to manage our reservoirs for electricity, and how to prepare for life-threatening floods. I mean, knowing a river's pulse is absolutely fundamental to our modern way of life. The heartbeats of our planet's greatest arteries are changing, and learning to read and anticipate these new, unfamiliar rhythms, well, that's one of the greatest challenges we're all facing right now.